As you can see here, there's just some examples of some inequalities that we're trying to solve to be able to find a value or values that a variable can be to satisfy each of these inequalities. The properties of inequalities are going to be really relevant. So basically, in a nutshell, we just saw that if you add or subtract anything to both sides of an inequality, then the comparison that you had to begin with is still going to remain true. So if you had a greater than, then it's still going to be greater than. Is where we're multiplying or we're dividing where we have to watch out. We don't have to worry about multiplying or dividing both sides by a positive. The direction of the inequality stays the same then. But if you multiply or divide both sides of the inequality by some negative number, then you have to change the direction of the inequality when you apply that to both sides, as we just saw. All right, so as we go into the first one right here, you can see that we've got y minus negative 1 4/5 is greater than or equal to negative 8/15. So to solve this, we want to isolate the y. Now you do have a subtraction of a negative, so we do have it such that y is adding with this. So we have y plus 1 4/5 is greater than or equal to negative 8/15. So if I want to isolate the y here, I'm going to want to subtract to undo the addition. Now when you subtract, you don't have to change the direction of the inequality, so this inequality this inequality is going to remain all the way throughout. So we're going to have to subtract 1 4/5 from both sides, and then that's going to result in giving us y is greater than or equal to whatever the answer to negative 8/15 minus 1 4/5 is, right? So in order to subtract these numbers right here, it would probably be really nice to get this guy to also be a improper fraction, so it has a numerator and denominator as well. So if you change that to an improper fraction, it's going to be 9/5 that we're subtracting away. And then, of course, if you're subtracting fractions, you're going to want to get a common denominator. So since our denominators here are 15 and 5, the least common multiple of them would be 15. So that means we don't really need to change that fraction. I mean, you could multiply it by 1 over 1. But this guy right here, you're going to want to multiply by 3 over 3, which is 1. But what that really gives you then is it gives you an equivalent fraction where you've got 27/15, which is the same thing as 9/5. That then you can take the negative 8/15 and subtract away. So we're going to end up getting then a final result of negative 8 minus 27 is going to be negative 35. So y is going to be greater than or equal to negative 35 over 15. And yeah, we can reduce that. Both are divisible by 5. So this will turn into y is greater than or equal to negative 7 thirds once we get that all reduced. So that would give you the solution right there. I think I did say to graph the solution set, so that would just be basically graphing all of these numbers for y on the number line, right? So if you're to graph this, here's our number line, here's negative 3 and negative 2 and negative 1. Negative 7/3 is going to be negative 2 1/3, so it'd be right there is negative 7/3. So y is going to be all the numbers that are equal to or greater than, so it'd be that which I graphed right there. And notice that the dot that I did make right there is a filled-in dot because we want to include the negative 7/3 there. All right, as we go to the next one right here, one step and we'll be done with this. So in this right here, we're going to want to multiply by negative, so that negative times negative turns this positive, and then 3/5, because then you're going to get 15 over 15 times k, and then you'll have to multiply this side by the same thing to keep it balanced, which is negative 3/5. So what you're doing to both sides in this one is you're multiplying both sides, but you're multiplying by a negative. And what that means then is the inequality symbol is now going to have to change directions and now become a less than when we do this. So if I put the 20 over 1 then you can see we're going to get negative 60 over 5. And then we can simplify all of this. So the 15 over 15 is 1k is less than, and negative 60 divided by 5 is negative 12. And that gives you the solutions for k. If you graph the solution set for that, then it'll look something like this. Open dot, and all the numbers that are smaller than negative 12. All right, in the next one, in order to isolate this variable p, you're going to have to get rid of the 3, which you could do by dividing by 3, or you could multiply both sides by 1/3. Either way is fine. So you just need to divide by a positive 3. So when you divide by a positive, you don't have to flip the direction of the inequality symbol, so it will still remain a less than, and then if you divide that, it's actually just negative half. If you want to leave it like that, that's totally fine. It's probably pretty standard where a lot of people like to have the variable on the left-hand side of the comparison. So if you wanted to write it where p is on the left-hand side, then note that if negative half is smaller than p, then that means that p is greater than negative 1/2, right? So those two statements, they mean the same thing. The second one probably is just kind of, I don't know, more common for people to write out. Yeah, and then if we just graph this, here's -1, here's 0, we need negative 1/2, and p is all the numbers that are greater than it with the open circle, since we're not including the negative 1/2. All right, and then for this one right here, we just need to get rid of the dividing by -4, undo that to get the a alone. So that means that you're going to have to multiply this side here by -4. So because we're multiplying by a number that is negative, the direction of the inequality is going to have to change here. So it will become a less than or equal to rather than a greater than or equal to. You're going to get just the a on the left-hand side there, and then a negative times a negative on that side is going to give you a positive. Ends up giving the number 48. And that gives you all the possible numbers for a equal to 48 and below. So if we graph that out on a number line, and if that's where 48 is, then we can include it. It's equal to, and then all the numbers that go below that.